Hello, I'm going to be talking about the Piwars robot I've been making, and a little bit specifically about something I'm adding to the top of the robot. So far we've got the internal electronics with the battery fitting, a pair of interlocking 3D printed parts. They kind of friction fit the battery and there's a clip here to keep it in. The Raspberry Pi and the motor controller. You got motors, they're actually going to have encoders on them, wheels and a caster. What we're going to focus on today is what's going on the top here and what I've nicknamed the Roofrack. There is a set of holes here and I'll take you through how they're done and then we're going to actually put the holes on the real physical robot. So the roof rack is going to be bolted on and it's going to be Lego compatible. I was looking at various ways to make it so I could adapt and change things that were fitting on the robot in the field. So the first thing I'd started to do was kind of look at camera linkages. I was kind of coming up with some kind of pantograph system. How would I make it rigid? How would it snap? This was kind of complicated and didn't give me the flexibility I might want. I'm thinking of a low position for line following, as I'm going to try and do that with the camera. A high position for the eco disaster event where you've got to look at barrels. Low position is down here, high position is up here. And I was even thinking, well, maybe you can make it servo driven. This is only part of the solution. And I was coming up with carriages that would go on either, say, some kind of a slider, like a fork style slider. I was looking at using angles like this and extending them back. One of them would clip to one of those pantographs. These quarter sections behind would kind of slide in a slot. They'd give me some flexibility with the camera, but they weren't really accounting for the rest of what I wanted to do. I've been a Lego user for years and I thought, well, friction fitting works beautifully for Lego. So I actually modelled this part, I printed it, and as you can see from this picture and this picture, it was not great. I mean, it's fun, but I'm making a janky kind of Lego. Not sure that's the right way to approach this. So where I went after that was starting to look at something that might actually be Lego compatible. And so I made this quite blocky thing where I'd actually taken dimensions both using my own calipers and from places on the internet to make a part that would clip to Lego. So I started by sketching a rectangle. We got 3 circles. Now this diameter has got some accounting for the 3D printing, so it is within 0.4 millimeters. Fit the clips, but not so much that it'll be tightly fitting them. And it kind of works, even the friction pins work. I had to do a few runs with some slight changes here for account for tolerance. So these circles are all set to equal projected cylinders. Created these further circles here. This was cut into one side, projecting them and cutting them on the other side. So then I took this Lego design a lot further and I created a camera mount so I can use the 3/4 length Technic pins. And then the Raspberry Pi camera will be bolted on the back with the camera poking through, and there's also space for that Sunny connector as well. So the first sketch here is the basic plate with the screw holes and the mount for the camera. Extruded that to make this frame here. These rectangles here were what that sketch was about, so those were just extruded as bars. On the side of one bar I stuck the inner holes, extruded those through both sides, through all, and I went and had a bit of fun rounding off corners just to make it look a bit nicer. The next sketch would have been the outer holes, and first I extruded those, then I created a center plane through this part and mirrored them to that side. Created a center plane here, mirrored them through to this side, the whole set. The final thing was to add this text, which I imported as an SVG. Here's a top tip: don't use the text parts inside Fusion. They're not great. It's using Inkscape to create text designs, exporting them as raw SVG and importing them. And you've got to make sure that you've got the trace outliners path set in Inkscape, so they're no longer text objects in Inkscape either. And finally that is cut into there. So here is the camera part 3D printed. Didn't need a lot of finishing. I mean, there's a little burr there that I can take off, but it's not really a big deal. So these pins, they snap in like that. Bolt that through here. Now this assembly is just a test assembly to show that it's compatible with Lego. The width here was designed to fit both the camera and to be compatible overall with Lego measurements. So that's the camera part, but the next thing I need is what's going to go on the top of the robot. And we come back to the part that I have called the roof rack. This part I actually started with the Lego holes, and it kind of has a feel of being much more like the studless Lego, or the lift arm pieces as they're known. So I extruded this part, there's the smaller circles, cut those, mirrored them. So I've only done one side. Extrude that, create myself a mirror plane, and mirror that segment. Now the thing is, when you mirror this section here, this feature, it creates it as a second body, and you can see how this side it's one body, and that side it's two. If you're going to 3D print this, you must join the two bodies, otherwise you're going to get some strange geometry between here if it thinks there are two parts. The next sketch is creating a bunch of mounting holes, so push those holes through. So if I recess the head of a bolt, then it won't interfere so much with whatever else might be clipped. There's a gap there for a bolt head, the logo for a bit of fun, which I've cut into there. Mini Orion robots, my daughter's going to make another one of her own, following kind of the same formula, sketching and building it herself, but she's going to put her own logo on it. So it's come off a 3D printer. A little bit of cavitation there, I'm not entirely sure, it might be just my bed needs to be replaced. But on the top here, the logos come out beautifully. These have come out wonderfully and appear to be able to fit into Lego parts. We've got the nice recessing for a bolt, but it's not going to stick out by much, so it should still be quite happy with Lego in there. But then I needed to put them on top of the lunchbox. I've created a series of holes. This is what we're going to drill shortly. So we have each of these 4 holes is for a roof rack piece, and the distance between them was measured to make sure it's compatible with Lego. Slot here is for the Raspberry Pi camera cable. These 3 big holes are for any other cables we might need, so GPIO, power, etc. And then what I did with this is I've turned this into a 1-to-1 A4 drawing, and that was so I could do this. So I want to be able to drill out all of the holes that I've drawn, and I've just taped them down to the side. Painter's tape is great because it comes off nice and easily, and hopefully it'll keep all of these holes together. These 8 holes here are the ones that need to be most accurate, and I don't really know how I'm going to get this slot in, and maybe try something with a Dremel cutter. I've now clamped this in. Now there's a bit of flex on the paper, but I've got actually bending around this box. I basically created a shim using 2 blocks of scrap wood, and let's see how well this works. That was kind of odd. It kind of went through and then went straight through. I don't know if that just bashed through there. That might not be enough clamping to make it work well. What I'm going to do with these 3 holes, I'm going to take the 3mm to make a pilot, and then I'm going to go back over with larger bits. Going straight in with 10mm is going to be kind of awkward. Let's try a larger bit. 7. And from 7 we should be able to go straight out to 10. I was expecting this desk to be in pristine condition, so that's fine. Now notice what's gone on here is it's torn great big tear marks where that went in. Right, now got the other problem, which is, does my chuck actually fit the 10mm bit? I hadn't even thought of that one. Oh, just about. Not going to get any larger without getting something bigger. Oh dear, it's not just the paper that is split here. Yeah, look, that's actually split plastic. It's not going to be a dreadful problem, it's just going to look a bit shonky. Maybe I need to just actually cut through there with a saw instead and just turn it into a slot. Make it look like it was intentional. What I'm going to try, and I have no idea if this is the right way to approach this, I'm going to take a cutting disc along this edge and this edge. This may just destroy the paper, but let's see how well this works. Here's the problem, taking out the side. Right, how much of that actually went through anywhere? It's mostly gone through. It's very messy. Maybe I should have drilled out circles on the sides. Bit of a pig's ear, but I think it's going to work. So let's open this up. What I can do is I can use cutters and sanders to try and tidy up. I can't really do anything about the overcut here, but I guess using a circular disc, what did I expect? Right, interesting that's torn off because that piece of paper is obviously bent round and embedded in here. If these work for 3D printing, they'll work for this. So I'm just going to do a teeny bit of cleaning up here. Let's just screw that paper off. well and truly embedded. It's actually an awful lot holding it on still. Might I have been better off doing this just with a knife, this particular slot? Quite possibly. Here now. This is a £1 shop lunchbox. In fact, it was worth less than £1 because it came in a pack of 3 or something, you know, so it is as cheap can be. So the fact that it broke, not surprising. Will it still work? I think it still will. I don't think I've actually compromised the overall structure of it, so this will still work even if it's a little bit messy. Ooh, and that pinged off somewhere. I wonder if I just cut through these, as in go cut through those slots completely where it's split, and then potentially later go and sand and file down, which out those ping quite violently. I might use the Dremel when it's charged up again to basically take those shoulders out and make that into a slot as well. There's a big slot down the middle instead of 3 slightly iffy holes. Since the Dremel needs charging, I'm going to do that by hand. This is rough as anything. Right, I've got to watch out then with those 10mm, so I should have perhaps taken a few more. When I said I've jumped from 7 to 10 or even 3 to 7, I maybe should have gone piece by piece to ream them out instead of that, so I wouldn't have split it. The inside is again quite rough here. Now I have got goggles on because I don't want this pinging anywhere near your eyes. First of all, I'll just check this all lines up nicely, which it should do. Yep. And these 3mm holes came out a little bit less than 3mm. Take some burrs off. Right, the other place where I've seen some burrs is right in those Lego fittings. So I'm going to get a circular profile needle file in there, just to take those off. That's going to be the most gentle job I can do. Right, I'll just make this, take a bit of pride in this bit. The habit, I know, there's not a lot of pride left in what happened down there, but right, that should bolt nicely onto here. One on here, on this side. In fact, hold on, it should be, that's the front, it should be this way up. So we'll bolt that on. Okay, so I found 4 of these hex head screws of the same length, and hopefully it doesn't poke out too much through the bottom. It should be just enough to go through. Nylon nuts. I'm not making them incredibly tight yet either. What I'll do is I'll come back home with my spanners. So one of the things I actually found with building this robot is I used the micro metal gear motors, and I used the rather cool little Piwars brackets for them. Now the Piwars brackets came with these white nylon flathead screws, and the problem with those is they seem to skip threads. I mean, not just cross thread, but skip threads as soon as you put any torque on them. So any kind of sideways force on them, and I'm sure as the robot spins around, is pretty quick, it gets some, and they slip. So the motors actually slip out a bit, and I want to see if I can find the right size in some metal bolts. Just hoping that they don't actually then go through the fact that everything else is then plastic. Okay, don't want to over tighten it because this is all plastic and you'll get damaged if it's over tight. Cool, that is the roof rack fitted. Pop that on there like that, and that's him. Now it's slightly suffering in the fact that back here this is not the best quality lunchbox I started with, sadly, but it's come together. We have the roof rack fitted. I may have to do something about the fact that these clips are not particularly rigid, but that might be good enough. So next thing to do is to build some kind of Lego adapter for this. Oh, now that's riding high on top of those bolts. That could be a problem. Maybe I needed a little neck on these to get them clear of the bolts, or maybe I need to try and find bolts with slightly less pronounced heads. The simpler answer was to go from M3 screws to M2.5 screws, and that actually gives it enough clearance up here. They still hold through quite well, but they all line up pretty nicely. It's quite smooth, really, so I can now call that ready to go. So now all I've got to do is create the actual camera mount that goes and brings it down under here or up over here. That is ready for the next stage. So if you've enjoyed that, give me a thumbs up. If you want to see more of me, you can either subscribe to this or you can go to @OrionRobots on Twitter and go make stuff and be awesome.